Welcome to the channel Physics Made Easy. Today we will discuss section B of the ISC sample paper. In this section, question 2 to question 12. 11 questions are there. Each question is of 2 marks and internal choices with 2 questions. Stay connected till end of the video. Let us see the question 2. An electric bulb is rated as 220 volt 100 watt. Calculate electric current flowing through it when it is operated at 220 volt, resistance of its filament. You know, there are the relations for the bulb given by V square by R and current I will be P upon V. These two relations will be used here for having current. You know, I equal to P by V, so P is 220 volt, 100 watt and V is 220 volt. So what will be I? You will get I here, this 100 upon 220. This will be the 0, 0 cancel, around 0.4. This will be the current. Okay. So this will be 10 upon 22 ampere. What about resistance? Resistance will be V square upon P. So what will be the resistance value? That is 220 into 220 upon this 100. P will be here. So that will be 484 ohm. Okay, this question has choice, this OR part. A and B represents VI graphs for series and parallel combinations of two metallic resistors. Which one represents parallel combination and why? You know, in the Ohm's law experiment, VI graph, if you plot V and I at the y and x axis here like this, then slope of the graph V by I, change in potential difference upon change in current, gives the resistance. In series combination, resistance increases, so slope will be more, and in parallel combination, net resistance is lesser, so slope will be lesser. Here B graph is of more slope as compared to A, so this will represent the series, and what will A represent? Parallel combination. So what will be the answer? Parallel combination and why? What will you write? A, because its slope is less and in parallel combination the net resistance decreases, and resistance is given by the slope of VI graph. So this is the reason. Question 3. Define ampere in terms of the force between two long straight parallel current carrying conductors having current in the same direction. Look how important is this derivation. If it is given to write the expression of the force, so you will also learn how to find the expression. It is not given how to derive, but I am showing you that if this is a wire straight long current carrying conductor having current I, and from R distance, perpendicular distance from it at this point, what will be the magnetic field? You know, magnetic field will be perpendicular to the plane downward, and this magnetic field will be given by mu naught upon 4 pi into 2I upon R. Suppose in this magnetic field another parallel wire, long straight parallel wire is placed, okay, and having current in the same direction it is given, then what will be the force acting on it? Law this BIL. Okay, B is here, this one, I is here, this one, and force in this direction. Similarly, this wire will experience force in this direction. Both will attract each other. With how much force? This force will be BIL. This I both are same. What is B here? Put the value mu naught upon 4 pi into 2I into I upon R into this L. How will you define ampere? Look, this F upon L will be this mu naught upon 4 pi is 10 to the power minus 7, then 2 into 10 to the power minus 7 I into I upon R. Define ampere, learn. I am going to tell you definition. 1 ampere is defined as that force if in air or vacuum two long straight current carrying conductors are placed at the distance of 1 meter apart and current flowing through them is in the same direction, then force of attraction per unit length is, if 2 into 10 to the power minus 7 Newton, then current flowing through them is 1 ampere. So learn how to make definition from this important expression. Okay. Question 4. Find the electric field at the midpoint of the line joining two charges plus 3 and minus 3 microcoulomb separated by 20 centimeter. Look here, any question is given, then how to solve it? Draw the figure. If it is given, this one charge is plus 3 microcoulomb and at point A it is placed, and this one charge is at point B and minus 3 microcoulomb. You have to find the force at midpoint, electric field. Midpoint is suppose O, then this AO and OB both will be 10 centimeter or 0.10 meter each, because net distance is 20 centimeter between the charges. What is the electric field? Electric field is a vector quantity. Look the definition and direction and magnitude both. At O, due to plus 3 charge away, that is towards B, this will be the electric field intensity's direction. At O, due to minus 3 charge, you know electric field direction is due to minus charge towards the charge, so this will be also in the same direction. Charges are same, distances are same, then any of the force you calculate and make the twice. What will you write here? This will be 2 into this 1 upon 4 pi epsilon naught, this 3 into 10 to the power minus 6 upon this r square, that is 0.1 whole square. In what direction? Towards B. Now simple calculation is left. So what will you get here? This 2 into, what is this constant? 9 into 10 to the power 9. So 2 into 9, 18, 18, 3 ja 54 into 10 to the power 9 into 10 to the power minus 6 upon, this is 0.01, that is 10 to the power minus 2. So what is left here? This is simple. You will get here, this is 11, 11 minus 6, 5. So 5.4 into 10 to the power 6, because 5.4 Newton per coulomb. And in what direction? You have shown in the figure, and also write towards B, that is towards negative charge. In this way you have to write the answers. Next question is, define self-induction in a coil of L equal to 5 Henry. Find EMF induced if a current of 2.7 ampere in it is stopped in 1.35 seconds. Look, how to solve this question? You know, EMF is induced in a coil when in the same coil the magnetic flux linked with it changes. We have read the expression, this induced EMF is minus L di by dt. How will you define self-induction L? Self-induction is defined as, it is equal to that EMF which is induced in a coil when in the same coil, through the same coil, rate of change of current is 1. You know, this is 1, then E equal to L, minus sign because of Lenz rule. So learn again, coefficient of self-induction is equal to that EMF which is induced in a coil in which the rate of change of current is 1. How will you solve the numerical part? Look here, in a coil of L 5 Henry and current changes 2.7 ampere in this much time. Look here, simple, this is 5, magnitude of EMF will be 5 into 2.7 upon 1.35. Simple, this 5 into 2, that is 10 volt will be Again choice question. In this figure, look, there is a cross magnetic field. It is written, in the uniform magnetic field of 0.5 Tesla, a conducting rectangular frame PMNO is placed with Mn side of length 20 centimeter and resistance 2 ohm movable. This side is movable and its length is 20 centimeter, its resistance is 2 ohm. If V equal to 10 meter per second, calculate the EMF induced in Mn and direction of induced current in Mn. Look here. Motional EMF we have read BVL sin theta. Here since field perpendicular, V is in this direction, theta is 90, sin 90 will be 1. So put the value. If you learn the relations, B is given how much? 0.5. So 0.5 into velocity is given 10, yes, and length is given 20 centimeter. So you write here this 20 centimeter. What is this 20 centimeter? You write directly 0.20 meter. Pay attention on units. Then this will be 10.5 and this will be 1 volt. Okay. What will be the current? You know, current will be EMF by R. Then this 1 by 2, R is 2 ohm it is given. Then this will be 0.5 ampere. How to find the direction? The induced current is obtained by right hand rule. Look here, magnetic field, this is the direction of induced current, this is the thumb denotes the motion of the conductor in the magnetic field. Look here, this will be, so from M to N, look the middle finger downward. So from M to N will be the induced current's direction of induced current from M to N. Clear? See the question 6. First part, define depletion region in a PN junction. You know, depletion region, as per its name, it is a small region in the vicinity of a junction which is depleted of charge carriers, free charge carriers, that is electron and holes. It contains only immobile ions. So this is the definition of depletion region. Again, a region near the vicinity of the junction depleted of charge carriers. Second part, how does the thickness of depletion region vary if with increase in reverse bias? When the PN junction is reverse biased and bias voltage increases, then this thickness depletion region also increases. These two questions, I think these two will be clear to you. Seventh question, in photoelectric effect experiment, plot the graph between stopping potential versus frequency and show that its slope is h upon E, h Planck's constant, E charge of the electron. Look, in the experiment of photoelectric effect, if this is the stopping potential, this one, it is shown as by V0, and at this axis frequency. Then for a particular substance, we get the graph like this. You know, the graph which intersects the x-axis at this point, this is called threshold frequency. Slope of graph is asked and prove that this is equal to h by E. Simple formula slope, you know, slope is given by change in y-axis upon change in x-axis, that is V0 upon this nu. Then how will you write in terms of energy? You know, energy can be written EV h nu can be written. So to make this energy simple, you can write this EV0 upon E nu, that is division and multiplication by E. This energy can be written as h nu or not? You know, h nu. So replace this energy term with h nu and this is E nu, as it is nu is cancelled. What are you getting? This h upon E. So learn how to get this expression to show the slope is h by E. Next question, what is the shortest wavelength present in the Paschen series of spectral lines of hydrogen. We have read 5 spectral series beginning from Lyman, Balmer, Paschen, bracket, Pfund. So, the formula for wavelength in general is given by 1 upon n1 square here, 1 upon n2 square, 1 upon lambda equal to Rydberg constant within bracket 1 by n1 square minus 1 by n2 square. If the first series, then put n1 equal to 1 and n2 2, 3, 4 onwards. We are here in this question, it is asked for Paschen series. Paschen means third, that is you will write here in place of n1 3 square. And shortest wavelength means that n2 will be infinity. So, in this expression n2 will be infinity, then what will you get? Simple, this r upon 9. Will you get or not? Don't leave your expression at this point. This is equal to 1 by lambda. It is asked what is the shortest wavelength. That means you have to write the answer by reversing it. That is 9 by r. Rydberg constant given in the paper. You can find in terms of meter also by putting the value of Rydberg constant. Otherwise 9 by r in terms of Rydberg constant. Next question, this one. Arrange the radiations, X-rays, radio waves, infrared rays, microwaves in descending order of wavelength. See the electromagnetic spectrum video. I have given total description about electromagnetic spectrum. These are the waves given. Then you have to learn that it is given in the descending order of wavelength. Then wavelength increases from cosmic rays, gamma rays to the radio waves. It is given descending order. Then how will you write? What will be your answer? The radio waves you will write at the number 1. Okay. Then before radio waves, you know, this will be microwaves. Then microwaves, after that infrared and infrared X-rays. So, in this way you will find descending order of wavelength. You will write here in descending order of wavelength, then radio waves, then microwaves, then infrared ray, then X-rays. Second part, which part of electromagnetic spectrum is used in radar system? Simple, you know, microwaves. Learn the applications of the various waves in the electromagnetic spectrum. How are they produced? What are their uses, applications? See the next question. Question 10. Obtain the binding energy in MeV of a nitrogen nucleus. This is the question. If you know the formula for binding energy, then simple calculations you have to find the answer. How will you find? Look here. You know, in the nucleus, in the very tiny, very small space, all the nucleons have to stay there. So they stay in the very small space due to largest force of attraction called nuclear force. Due to nuclear force, they are bound together and they are contained within a very small space. This mass defect you have to find first, and this mass defect in atomic mass unit multiplied by 931 MeV gives the binding energy. How will you find this mass defect? This mass defect is the mass of nitrogen nuclei minus mass of nucleons. How many neutrons and protons there? You know, 14, 7 means 7 proton and 7 neutrons. Then you have to write here this mass of 7 proton plus mass of 7 neutron with the small n. Then you can calculate, these are the values given. You can find the mass defect and if you find this mass defect, then binding energy, how will you find? Binding energy will be this delta M into 931. So this you will get, put the value and solve this mass defect. I have calculated, because this 7 times this will be added, then this addition will be subtracted from this one. So this result comes at binding, and this difference is 0.11243, and this is multiplied by 931. So you will get here, this will be 104.67 MeV. I have calculated it to just you do yourself and check with the answers. In the question 11, in the figure find F2 if F1 is 80 centimeter and the distance between both the lenses is 20 centimeter. Look, parallel set of rays are coming at the F1, that is convex lens. It is given 80 centimeter focal length. You know, parallel set of rays are focused at the focus point. From infinity they are coming, so u will be infinity. So what will you apply the formula here? 1 upon v minus 1 upon u equal to 1 upon f1. Since u is infinity, so you write here v1, so 1 upon v1 will be 1 upon 80. It means that rays are focused here at the distance of 80 centimeter from the convex lens. Okay, here. Now this image I1 will be acting like the virtual object for this lens, concave lens. That's why what happens when the rays are focusing here, what happens here till this point, when the rays are coming here, you have to draw the figure like this. Okay, I am showing you this one. Okay, so that the rays which were actually converged a little are again here, it is shown they are again parallel set of rays were given in the question. For this lens, what will you do? Let its focal length is f2. What will you do here? That 1 upon f2 will be equal to 1 upon v2 minus 1 upon u2. Look here, this virtual object will be here, this u2 will be with positive sign because in the direction of incident ray. What will you write here? This will be 1 upon v2 that is infinity, you will write here infinity, minus 1 upon this u2. What is this u2? This distance is 20 centimeter and this total distance from here, this one, this is 80 centimeter as we have calculated the image distance from lens. So 80 minus 20 will be 60. So this will be 60. Therefore, F2 is minus 60 centimeter. Look again. This is the convex lens. Parallel set of rays will focus at 80 centimeter. That means from this lens 60 centimeter. So for this U2 will be 60 centimeter. And look here. From this expression, V2 will be infinity as the rays are finally parallel. So this 60, 1 upon F2 in this expression you will put here. Then this will be the minus 60 from this expression. It is clear. So this is the answer. Focal length of concave is negative also. So it is coming here. In this question 12, first part, state Brewster's law. You know, whenever there is a transparent material, at the polarizing angle at this material, if unpolarized light is incident at the Brewster's angle called polarizing angle also, then reflected and refracted light rays are perpendicular and reflected ray is completely polarized, while refracted ray is partially polarized. So, refractive index of the material, transparent material, is given as tangent of polarizing angle. This is called Brewster's law. This reflected ray is completely polarized, this refracted ray is partially polarized. What is Brewster's law? Just we have discussed. So, to know the Brewster's law, you should know what is angle of polarization. That angle at which if the unpolarized light is incident at the transparent material, then reflected and reflected ray, they are completely and partially polarized, and Brewster's law is given by mu equal to tan IP. Second part, find Brewster's angle for a transparent liquid having refractive index 1.5. Put simple here, this is 1.5 equal to tan IP. Then Brewster's angle, you know Brewster's angle or polarizing angle both are same. Then what will be IP? IP will be tan inverse 1.5. It is about 56 degree 31 minutes, but you have to write only this. This will be also correct. So, in this way you have to solve the questions. I hope you must have enjoyed. Thank you.